Good morning, guys. It's Miss B again. Today we're going to be working with adding and subtracting when you're involved with radicals. Now, this doesn't seem like a practical skill, and sometimes it's not, but as you get into your upper level classes, you're going to need it because there's a difference between the actual answer, the exact answer, and the approximate answer. And when you put things in your calculator and it's a square root or a cubed root, and it's not a perfect square or it's not a perfect cube underneath that root, you're getting an approximate. You're not getting an exact. And that's why we need to learn how, and that's why we've been working on writing the square roots and cube roots in their radical forms, in their simplest radical forms. Now, what we're going to do today is we're going to take that. We're going to take our numbers, we're going to put them in simplest radical form, and then we're going to either add or subtract them. Now, thing with adding and subtracting when they're in radical form, you've got to watch and make sure that those radicals are the same, because you know how when we were adding and subtracting like terms, when we're combining like terms, we had to make sure that all the variables were the same and all the exponents on each variable were the same before we could put those numbers together. That same thing applies with square roots. So let's get started on this today. So when we are adding or subtracting radical expressions, adding or subtracting radicals, the first thing we want to do is we want to simplify our radicals. We want to make sure they're in a form that we can deal with, and we got it down to the point where whatever's under the radical is stuff that we can't take out of the radical. Okay, we need to identify our radicals that have the same index and the same radicand. So when we're looking at this piece has to match and that piece has to match. Those two things are important, that they match. Okay, now for common radicals, add or subtract the coefficients. So like in our example here, first thing I notice is this square root of 20 is not in simplest form. So the first thing I have to do is figure out the square root of 20. Well, that's 2 and 10, which is 2 and 5. So negative 2 times the square root of 20 is going to be rewritten as negative 2 times 2 times the square root of 5 minus 2 times the square root of 5. Well, I need to simplify this part. So then it becomes negative 4 times the square root of 5 minus 2 times the square root of 5. Now, if we look carefully, the first term has a square root of 5, and the second term has a square root of 5, which means I can now combine the coefficients in front of them. So if I look at this and I cover up my variables, I have negative 4 minus 2. So that's going to be negative 6, and then I just rewrite what's at the end. Okay. So let's look at another example. Well, example number 1 is incredibly nice for us because if we look, first thing we look at, have the square root of 6 here, square root of 6 here. Everything is in simplest radical form and our radicands match. So now all I have to do is 3 minus 2. Well, 3 minus 2 is 1 times the square root of 6. But just like while 1 in front of a variable, you don't have to put it in. And so when you were looking on your paper for your answer, it would just be square root of 6. Now if I go down to number 3, first thing I'm going to do is check my radicals, and right here I have the square root of 63. Well, that's not in simplest radical form. So I'm going to go over here to the side. I'm going to do the square root of 63. 63 is 3 times 21, and 21 is 3 times 7. If I look at that, I've got 2 I can take out and 1 that gets left behind. So when I rewrite this, it's 10 times the square root of 7 plus 2 times 3 times the square root of 7. I I need to simplify this out. I need to make this so I don't have a bunch of things I'm looking at. So now it becomes 10 times the square root of 7 plus 6 times the square root of 7. Our square roots match. So now this becomes 10 plus 6, which is 16, times the square root of 7. Now, as we progress here, we're getting a little harder every time. So let's look at number 5. Number 5 is a little bit more difficult because I have the square root of 32 and I have the square root of 18. So the first thing I'm going to do is my square root of 32. 32 is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So I've got 2 sets of 2's that I can take out, plus the 2 that was already there, and a 2 that's left behind. Now let's look at 18. 18 is 2 times 9, which is 3 times 3. I have 1 set of 3's that I can take out. So I already had the 3 that was there, times the 3 I took out, with a 2 left behind. So now 2 times 2 times 2 is 8, square root 2. 3 times 3 is 9, square root 2. Our roots match. So now I've got to do 8 minus 9, which is negative 1 times the square root of 2, or you could just write that negative square root 2. Okay. Now, I'm going to give you about 5 minutes. Actually, no, I'm going to make it 3 minutes. And I want you to try number 4 and number 6 using 3 and 5 as your guide. right, guys, so let's look at how we did 4 and 6. Start off with number 4. We have the square root of 15 minus 6 times the square root of 60. Well, first we need to check and find out if both of them are in their simplest radical form. So if I look at the square root of 15, 15 is 3 times 5, so I can't break it down any more than it's already been broken down. But if I look at 60, 60 is 2 times 30, which is 2 times 15, which is 3 times 5. So I have those 2's that I can take out. Now, so we go back to our problem. So the square root of 15 stays. Minus 6 times the square root of 60. Well, the square root of 60 is 2 times the square root of 15. So now I have 1 on the square root of 15, 1 times the square root of 15, minus 12 times the square root of 15. My square roots match, so now I'm going to do 1 minus 12, which is negative 11 square root 15. On number 6, I have the square root of negative 4 times the square root of 28 plus 4 times the square root of 112. First things first, check to see if these are in simplest radical form. 28 is 2 times 14, which is 2 times 7. So I've got to rewrite it. I had the minus 4 on the outside already, times 28 in square root of 28 in simplest radical form. So this becomes 2 times the square root of 7. Now, 112. It's an even number, which means it can be divided by 2. 2 goes into 11 5 times, 2 goes into 12 6 times. Okay, it's 56. And then 2 goes into 56 28 times, and 2 goes into 28 14 times, and 2 goes into 14 7 times. So let's see. We have 2 groups that we're pulling out. So 4 times 2 times 2 times the square root of 7, because our little 7 got left behind. So now I have negative 4 times 2, which is 8 times the square root of 7, plus 4 times 2 is 8, and 8 times 2 is 16 times the square root of 7. Now, our square roots match, so we move to our coefficients. Negative 8 plus 16 is 8 on the square root of 7. So as long as we are careful and make sure that we have everything in simplest radical form, and then we combine our coefficients carefully, we should be in good shape. Does this change when I go from a square root to a cube root? Nope. Same idea, same practice. Most of the time when you see this, though, in your future math classes, it's going to be just like this. It's just going to be the square roots. Now, why do we need to know this stuff? Well, lots of times they come into being practical problems. You know, you don't always get to measure out things exactly, especially if you're dealing with triangles. So let's look at these practical application problems, okay? Word problems, you know, everybody's favorite, almost as fun as fractions, okay? It says, write the perimeter of the triangle as an expression in simplest radical form. Okay, so perimeter means what? It means around the edge. So we're looking for the measurements around the edge. Well, this is a triangle. It's got 3 sides, which means I have to add those 3 sides together. So let's look at this. I have 8 times the square root of 18 plus 16 times the square root of 2 plus 2 times the square root of 72. Now, the only one that's written in simplest radical form right now is this one in the middle, 16 times the square root of 2. So now I got to figure out the square root of 18 and the square root of 72. We'll come over here to the side where I have more space. 18 is 2 times 9, which is 3 times 3. So 8 times the square root of 18 gets rewritten as 8 times 3 times the square root of 2. And that's 16 times the square root of 2. Now I got to do 72. Well, that's 2 times 36, which is 2 times 18, which is 2 times 9, which is 3 times 3. So I have a set of 2's, and I have a set of 3's. So now I'm going to go over here, and I'll write the 2 I already had. The square root of 72 in simplest radical form is 2 times 3 times the square root of 2. So now let's simplify these a little bit more so they're easier to add. 8 times 3 is 24 on the square root of 2, plus 16 on the square root of 2. And then 2 times 2 is 4 times 3 is 12 on the square root of 2. Now let's look. Square root 2, square root 2, square root 2. So all my radicals match, or all my radicands match. So now all I got to do is add my numbers. 24 plus 12 is 36. 36 plus 16 is 52 times the square root of 2. Okay? And that's how these problems go. Now, sometimes they're not nice enough to give you a picture because, you know, it is a word problem after all. It's a real world situation. The length and width of a rectangle is represented by the expression 2 on the square root of 405 and 9 times the square root of 48. Write an expression to represent the perimeter of the rectangle in simplest radical form. Well, first of all, it's a rectangle, so let's draw that out. Okay, now, once we have it drawn out, we have one side that's 2 times the square root of 405, and the other side, which is 9 times the square root of 48. Because it's a rectangle, we can figure out, we can, you know, infer, to use a nice English term for Miss Bunn, what the other two sides are. Now, perimeter means we are adding the 4 sides together because we want to know how far it is around the outside of this shape. Well, for us, what's nice, because this is a rectangle, I only have to figure out the square root of 405 and the square root of 48. So I'm going to go over here to my side again where I have a little more room. I'm going to start with 48 because it's the smaller number. Okay, 48 is 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. I'm going to end up pulling out 2 sets of 2's for that. So the square root of 48 is 2 times 2 times the square root of 3. So that's 4 times the square root of 3. Now we're going to do 405. Well, it's not even, so I can't divide by 2, but it gives us a nice hint here. It ends in 5, which means it has to be divisible by 5. 5 goes into 40 8 times, 5 goes into 5 once. Okay. 81 is 9 times 9, and 9 is 3 times 3. I know I did that factor tree a little different, but sometimes some of our math facts are a little bit easier to remember, okay? Now let's look. The square root of 405 is 3 times the square root of 5. So that's 9 times the square root of 5. Now let's take these two and put them back into our problem. This becomes 2 times 9 times the square root of 5 plus 9 times 4 times the square root of 3 plus 2 times 9 times the square root of 5 plus 9 times 4 times the square root of 48. All right, now we've got 18 times the square root of 5 plus 9 times 4 is 36. 36 times the square root of 3 plus 18 times the square root of 5 plus 36 times the square root of 3. Now, slight problem. I have 2 that have the square root of 5, and I have 2 that have the square root of 3. Just like if I had 2 that had x and 2 that had y, you only combine the ones that have the matching radicals. So I'm going to do 18 plus 18 and get 36 square root 5. And then I'm going to do 36 plus 36 and get 72 square root 3. Now, this is in its simplest radical form because I cannot combine something that has the square root of 5 with something that has the square root of 3. Today's lesson, guys, was super short. That's okay. That's the way we want to keep it some days. If you have any questions, either please put them in the comments or get in touch with me. Just as a reminder, from now until school's out at the end of May, my office hours are 9 to noon on Monday through Friday. Always just message me, let me know, and I look forward to your next lesson.